Welcome friends, welcome to my another new video. As you can see, I have selected this beautiful problem from JEE MAIN 2019. And it is a kind of real life mathematical problem. And as I have promised, I will show two different ways to solve it. And you may opt for the way which you feel more easier. So without wasting any time, let's start solving it. Suppose that 20 pillars of the same height have been erected along the boundary of a circular stadium. So first we will draw a circular stadium. So 20 pillars will be erected. So we will just take 20 positions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. So name this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. So these visualize that these are the position of 20 pillars of same height around the circular stadium. Now it has been told that if the top of each pillar has been connected by beams with the top of all its non-adjacent pillars, then the total number of beams is. So if we select this pillar number 1, for example, we select the pillar number 1, then it has been told in the question that 1 can be connected to all other top of the pillars except the adjacent pillars. That is, we cannot connect pillar number 1 with pillar number 2, and we cannot connect the pillar number 1 with pillar number 20 with the help of beams. That is the same thing, that the top of each pillar has been connected by beams with the top of all its non-adjacent pillars. So here it is very obvious that this pillar number 1 can be connected with other non-adjacent pillars, means top of other non-adjacent pillars in 17 ways. How? Because total top available in our hand is 20. Now we will subtract the pillar number 1 itself and the two adjacent pillars, that is pillar number 2 and pillar number 20. So 20 minus 3 means 17. So pillar number 1 can be connected in 17 ways to the other non-adjacent pillars. Now this pillar number 1 I have selected for understand the situation. Now we can easily, or we can choose any of the pillar out of 20. So that can be chosen, that is one pillar can be chosen or can be selected out of 20 given pillars in 20C1 ways, 20C1 ways. So for each of these 20C1 ways, each pillar can be connected to other non-adjacent pillars in 17 ways. So I claim that this will be the answer. But one thing you have to understand, that if here we have to connect the top of the pillars with beams, that is non-adjacent pillars. Okay. So now if we join the pillar number 1 with pillar number 11, Also, if we join pillar number 11 with pillar number 1, the both way we just need one beams. But in this collection, we have this both side beams. Means both side connections are, or both side ways are considered in this 20C1 into 17 ways. So we have to divide this by 2 to get the actual number of beams without repetition. So hope you have understood up to this. If you have any doubt, just rewatch this video, you can clear your doubts. You can also imagine the problem of handshakes. To make a handshake, 2 hands are needed. Suppose this is person A, this is person B. So to make a handshake, both hands are needed. So if he spreads his hand and he also spreads his hand from this side, then one handshake will be happened. So here we cannot claim that 2 handshakes are constructed between A and B. So similar case here, 20C1 into 17 ways include the all possible beams where this, suppose this point A, that is pillar 1 is connected with pillar 11, also pillar 11 is connected with pillar 1. Also this 20C1 into 17 ways include the join of this point, means point or pillar 17 with 7, and the vice versa, this 7 with 17. Also this similarly, this 20C1 into 17 ways includes the pillar or beams connected with the top of the pillar number 19 with pillar number top of the pillar number 9, also the vice versa, that is the beam connected from the top of the pillar 9 with pillar number 19. So that repetition we have to divide, we have to exclude by dividing by 2. Hope now this portion is cleared. So now we will do the calculation part. 20 into 17 by 2, so 10 into 17 equal to 170. So now we will check the options. See, option C will be the correct option. Now if you have any doubt in this process, I have to offer you another process to solve this beautiful problem. Now here we will erase this. See this diagram, way 2, process 2, second process. Okay, see this diagram. Here we can assume that this is a polygon with 20 sides and 20 vertices. Okay, suppose this is a polygon with 20 vertices. Now we know that to get a diagonal of a polygon, we have to join the alternative vertices, right? Alternative vertices. That is, if we take this vertices 18, then to get a diagonal, we cannot join this 18 to 19 or 18 to 17. We have to join rather 18 to 20 or 18 to 16 or any other else. That is, the main catch is to get a diagonal from this pillar number 18, we cannot join the adjacent vertices. That is the same thing which has been told in the problem, that top of each pillar has been connected by beams with the top of all its non-adjacent pillars. That is, if we are able to find in any way to find that is, if we are able to find the number of diagonals of this polygon with 20 sides, then we are done. Hope you have understood. If you have any doubt, then please rewatch this portion. Your doubt will be wiped off. So how to calculate the diagonals of a polygon with 20 sides or 20 vertices? To find the number of beams, it is enough to find the number of diagonals of polygon with 20 sides. Now we know that a diagonal, to construct a diagonal, we have to have in our hand 2 vertices. So if we do this, we select 2 points, or if we out of 20, then it includes all possible diagonals. But is it okay? No, because if we select out of 20 points that which are the vertices of this polygon, from these 20 vertices, if we select 2, then that also generates the sides of the polygons, including the diagonals also. So to get the exact number of diagonals, we have to subtract. We have to subtract what? We have to subtract the number of sides of this polygon, which are obviously 20, because it has 20 vertices and sides 20. So 20C2 minus 20 is the required number of diagonals, or you can tell that is the required number of beams. So 20 factorial by 2 factorial by 20 minus 2 means 18 factorial minus 20. So 20 into 19 into 18 factorial by 2 minus 20. So 210, so 190 minus 20, see 170. Again we have in our hand number of beams are 170. So option C will be the correct option in either process what you can follow. So hope you have enjoyed this problem, and if you have any doubt left, please rewatch this video and your all doubt will be wiped off. And please do subscribe to my channel, because I have noticed that people are watching my videos but they are not subscribing to my channel. See, if you someday if you become a creator, if you open a YouTube channel, then you can understand how much effort you have to give for a single video. You have to do a lot of planning to select the subject of a video. You have to shoot the video, you have to edit and upload to the YouTube channel. So after investing a lot of time, you just expecting that your viewers will give a like, at least subscribe to your channel. I just expecting this little bit courtesy from you. It is totally free. It will not cost a single penny from you. So if you get really a little bit value from my videos, please do subscribe to my channel and motivate me and keep supporting me. And like this video and share this video with your friends. Don't confine this knowledge to yourself. Thank you for watching, and I will catch you in my next video.